Okay, I've reopened up the swyk for you, but you need to watch this video to get the code to get in. Okay, so the first thing that I see a lot of people doing wrong on the swyk is they're not color coding. Okay, so you need to color code on the swyk. So I don't know if that means you need to get out a separate sheet of paper and color code or what. And sketch a circuit and color code it or what. So that's the first thing. So the second thing is this. We found out that bigger resistors have the biggest pressure difference across them. So for instance, in the example I see above, I see B1 has 6 arrow tails through it, and I see that B2 has 3 arrow tails through it. And so I should know from that information which one is the bigger resistor. In fact, I should know how many times bigger the resistance is. And then when I look at the far circuit to the right, I know, since I know the proportions of the resistance, I know which one has the bigger pressure across it. And again, the bigger resistor has the biggest pressure. So let's just say that the ratio of the resistances were 4 to 1. So let's say one was 4 times bigger than the other one. That means the bigger one's going to have 4 times the pressure across it than the other one. So 1 step of pressure would be across the smaller one, and then 4 steps of pressure would be across the bigger one. And so you can kind of think of it as, okay, in the color code chart, 1 out of 5, because there's 5 steps there, 4 across the bigger one, 1 across the smaller one. 1 out of the 5 is going to be across the smaller one. And so you can think of it as 1/5 of that total number of steps. And I think if you put in all those, like red and then red, orange, and then orange, red, if you put in all those steps, I think there's 12 of them. So imagine 1/5 of that 12. So that would be what, 1 4/5. So almost 2 whole steps, either up from the red or up from the blue or down from the red. Okay. Now, I think some of these, it didn't give you those options of, like red, orange, and orange, red. So you're just going to have to imagine rounding that, which one's the closest one. And if you're like, well, why is that? Well, for the bigger resistance, in series, they both have the same flow through them. So in order to get the same flow through them, the bigger resistor is going to require more pressure to get that flow to go through it. That's why. Another thing that I noticed a lot of students make a mistake on problems like this was they were saying that, for instance, the color there at A is the same as one of either the top wire or the bottom wire. And so let's say red to red. So let's say the top wire is red and A is also red. Well, that implies there's no flow across B1. Or let's say the A is blue and of course the bottom wire is blue. Well, that implies there's no flow across B2. Well, that means also there's no flow at all through here. Well, that doesn't make sense. Okay, so that's not possible. Okay, so maybe you're saying it's close to blue, or maybe you're saying it's close to red. Well, then you need to pick a different color because there has to be a pressure difference across it. Okay, so the first number for the code to take the swyk is 9. Okay, some people had a problem with this one, and all I have to say for this one is you're not color coding. You're not sketching this. Even if you're not sketching it, trace it with your finger and imagine the color code. So I'm going to point out that you know that wire E is touching the positive terminal of the battery. You know that wire D is touching wire E. Okay. You also know that there can't be a pressure difference in a wire. It has to be the same color code. Okay, if it's touching another wire, they have the same color coding. The only time you can have a pressure difference is across light bulbs or across the battery itself. Okay, so you need to color all of these wires. They're touching things and you should be able to figure out. Again, you can only have a color difference, a pressure difference across light bulbs and batteries. You can't have a pressure difference through a wire, or if a wire is touching another wire, they would have to have the same color. Okay. The next 2 numbers in the code are 4, 3. Okay, this was another one. This is probably one of the more difficult ones that students would have to figure out, and I think there was various things here, but I was wondering to know basically the color code for A. Well, again, You just need to color code this thing. The biggest resistance has the biggest pressure difference across it. Also, we've learned that light bulbs, resistors, in parallel act like a resistance reduction. It's a division. It's a resistance division. So light bulbs 2, 3, and 4 are in parallel. That means the effective resistance of L2, 3, and 4 combined together is like 1/3 of a normal long bulb. When you have resistances in series, light bulbs in series, the biggest resistance gets the biggest pressure difference across it. Well, L2, 3, and 4 act like one light bulb with 1/3 the resistance of L1. So that means it's a smaller resistor. That means it's going to have a smaller pressure across it than L1. Okay? And you should be able to figure out the proportionalities for that. A wire, if it's touching anywhere, another wire, they have the same pressure across it. So A is going to have the same pressure as all of those wires leading from A to L1 or L2 or L3 or L4 because they have to have the same pressure. There's no resistance in those wires. The only time you have a pressure difference is across the light bulbs because they have a resistance to flow, and across the battery, which is acting like a pump to increase the pressure. The next number is 4. This is from a lab that we did. So on the right hand side, this is immediately after there was a connection here. So before the battery is even hooked up to it, of course, all the wires on the left-hand side, the left-hand circuit, they're all yellow, okay? But after the battery is connected, I should say immediately after, what we found out was that the flow into a bulb is not necessarily the same as the flow out of a bulb, okay? Or I should say, the flow at any point in the circuit isn't necessarily the same. So, for instance, up in wire A, there's more flowing into that wire because it's directly connected to the battery than what is flowing out there at 1 because that light bulb is acting as a kind of a dam. It's damming it up. So it's more is flowing in than what's flowing out. So since we have unequal flows flowing in and flowing out, then that's going to mean some stuff. That's going to mean either charges being added, and so it's getting compressed, or it's going to mean that charge is being depleted, and so that's going to lead to some pressure changes. And this last circuit, again, I could tell students aren't color coding. So notice this wire here coming off the R1 to the right is touching all of these wires. Okay, so if you color code these, you should be able to answer this pretty easily. Bigger resistance gets proportionally more pressure across the electric pressure. And we found out that a long bulb would have about 6 times the resistance of a round bulb. So if you had a long bulb and a round bulb in series, then that would be 1 pressure step across the round and 6 across the long. And so out of all the possible pressure across that circuit, 1 out of 7, because there's 1 step for the round and 6 for the long, so that's 7 total steps. So 1 out of 7 is across the round and 6 out of 7 is across the long. And if you're thinking of 12 steps of pressure for the 12 different colors, you can figure out approximately how much that is. Now, I don't think there's partial colors that is allowed here, so you're going to have to round it to figure out which one is closest to. Okay, so make sure you're color coding. Okay, the last number of the code to get into redo the swyk if you wanted to is 7.